Students, this final video installment of my Special Topics Lecture 2's coverage of a systematic review of chapters 6 through 8 from General Chemistry last semester is basically the crux, the climax of this coverage from these chapters. What I'm going to do in this video is just read to you a series of questions and problems from all these chapters. If you have the ability to do all of these questions and know what you're doing, then you've got this material down. I'll of course post links throughout to other videos that will help explain how to do these kinds of questions that you're welcome to consult if you need to. First, of course, I want to begin with a hilarious chemistry cat of the day from quickmeme.com, which says, "I practice chemistry yoga, balancing equations." I'd also like to introduce you to an interesting molecule of the day. Melatonin, whose structure is here, which is also known formally as N-acetyl-5-methoxytryptamine, is a hormone that is secreted by the pineal gland in mammals. It is also found in other animals, plants, and microorganisms. It helps regulate the circadian rhythms of biological functions. A.B. Lerner and co-workers isolated melatonin from cattle pineal glands in 1958 and characterized it a year later. The following year, I can't pronounce that name, et al. Published 2 laboratory syntheses of melatonin. Now, in humans, the melatonin signal forms the part of the system that regulates the sleep-wake cycle by chemically causing drowsiness and lowering the body temperature. But it is the central nervous system that controls the daily cycle and most components of the paracrine and endocrine systems, rather than the melatonin signal. Now, just for the sake of interest, I want to present you with a link to a Wikipedia article about this rare disease called fatal familial insomnia. I strongly invite you to read it because this is a very interesting disease. And that's pretty much it. So let's go ahead and get started. After this video, which will basically inundate you with a bunch of problems reviewing all of the material covered in chapter 6 or 8, you guys should be able to do every kind of problem that we'll review today from chapter 6 or 8. Are you ready? Let's go ahead and begin. Starting with quantum numbers. For n equals 4, what are the possible values of L? For L equals 2, what are the possible values of m sub L? And if m sub L is 2, what are the possible values for L? Separately, give the values for n, L, and m sub L for each orbital in the 2p subshell and each orbital in the 5d subshell. Now to electron configurations. Identify the specific element that corresponds to each of the following electron configurations and indicate the number of unpaired electrons it has. Now to another problem. What is wrong with the following electron configurations for atoms in their ground states? Now this problem. Write the condensed electron configurations for the following atoms using the appropriate noble gas core abbreviations. Now to ionization energies. Based on their positions in the periodic table, predict which atom of the following pairs will have the smaller first ionization energy. Remember, that's the amount of energy required to remove an electron. So the one with the smallest first ionization energy is the element that wants to give up electrons the most easily. Now another one. Why does lithium have a larger first ionization energy than sodium? And what is the general relationship between the size of an atom and its first ionization energy? And which element in the periodic table has the largest ionization energy, and which one has the smallest? Now to another subject, atomic radii, which is a fancy way of saying the sizes of atoms. How do the sizes of atoms change as we move from left to right across a row in the periodic table, and from top to bottom in a group or down a group on the periodic table? Now to ionic radii, in other words, the sizes of ions. Explain the following variations in atomic or ionic radii: that I- is larger than I, which is larger than I+, that calcium 2+ is larger than magnesium 2+, which is larger than beryllium 2+, and separately that neutral iron is larger than iron 2+, which is larger than iron 3+. Now another question. Which ion is smaller, fluoride or sodium cation? And why? Now to another subject. Gas phase bond enthalpy, or just bond enthalpy. Using table 8.4 from the back of our text, calculate the change in enthalpy for the following gas phase reaction. And using that same table, calculate the change in enthalpy for the following gas phase reactions. Now we'll move on to another subject. Lewis structures. Draw Lewis structures for each of the following ions or molecules. Identify those that do not obey the octet rule and explain why they do not. That's the end of this video. If you've been able to do all of these problems and have a command of this material and these concepts, then congratulations, you know chapters 6 through 8. If not, please don't feel ashamed. It doesn't mean that you're a bad person. But if you're a student of mine in particular, I would invite you strongly to make sure that you practice until you get a command and a fluidity with these concepts, because you will be nailed with them on the final. And I want you to get a very, very high score. I'd like you all to get 100 on the final. I'd love it. Anyway, that's the end of this coverage. Please stay tuned to the next one, in which I'll begin teaching you about Special Topics 3, which is a systematic review of later chapters. Until next time, my wonderful students, have an enjoyable rest of your day.